Good morning or evening. I'm not sure which of these it may be, but we are going to be working on part 3 of your semester exam review. So let's look at this and see how we're going to start. Okay, so I last left off on the second number 19, which starts all these word problems that you're seeing, and we're going to be looking at, let's say, the different types of word problems. Now, again, these all fall into usually certain types. So, like number 19 is a perimeter problem. Every time you see the word perimeter, you're going to think 2L plus 2W. Okay, automatically start off with that. So that first sentence says the perimeter of a rectangular field is 356 meters. The perimeter, 2L plus 2W, is equals 356. There's your first equation. The length, L, is equals 7 more than, that's plus 7, twice the width, 2W. And then, how can I do this into the calculator? You got to remember, all the variables need to be on the left, answers on the right. So I need to move the 2W to the left. That would become a negative 2W. Whoops, that went too far. And then I could type in this equation and this one, 356, 1, negative 2, 7. Press enter, and I would get an answer of 121 for the length and 57 for the width. In centimeters. I think it was centimeters. Oh, take it back. It was meters. So there you go, meters. All right, the next one is a money problem. Those are actually fairly easy to set up, so I'm just going to show you the answer here. Cost of renting 3 tables and 12 chairs, 3x plus 12y equals 629. They go pretty much in order. Cost of 4 tables and 14 chairs is 789.10, and then you go ahead and, like, say, type them in, and there you go. So that one's, again, fairly easy. Okay, the last one, or not the last one, the next one is about mixture. Now, on mixture problems, you have a total equation that's always x plus y equals the total. Then you have a mixed equation that's like basically the same thing, but we're going to put blanks in front of the x, the y, and the total because you're going to have some numbers that multiply them. And they usually are listed in order. So if you look at the top 21, because apparently I have two 21s, I'm just not commenting on this, but on the top 21, the dried raisins worth $2.75 a pound were mixed with dried plantains worth $4.75 a pound to produce a mixture, so on and so forth. How much was for 36 pounds? So my total was 36. And then, for the mixture equation, notice how I already have this set up with some blanks. The mixture equation would have gone 275, 475 in order, and 371 times the 36. And you can type that into the calculator, and that will give you an answer just like that. So you would type in 1, 1, 36, 275, 475, and then 371 times 36. Okay, so I get an answer of, like, say, 18.72. Let me write this down here. X is equal to 18.72, and Y is equal to 17.28. Notice it does say round to the nearest pound, so that means my final answers would have been 18 pounds and 17 pounds. Oh, wait. I forgot how to round. Oy vey. 19 pounds, sorry, rounding up. And then 17 pounds. I was like, something done right here. And notice 19 plus 17 is 36. There you go. All right, so next one. The next one is a motion problem. Okay, motion problems start off like this. You basically are saying x plus y, x minus y. You've got time in front of it, and you got distance on the end. The plus one is the one that goes down with the downstream or with the wind. The minus one is the one that goes upstream or against the wind. So when I say Emma can row 45 kilometers, kilometers would be a distance. Downstream, I'm going to put the 45 here. And then I see in 3 hours. 3 hours would be there. She can row 27 kilometers upstream in the same amount of time. So that means, now you got to distribute, so that means you're saying 3x plus 3y equals 45. 3x minus 3y equals 27. And then you basically just type those numbers into the calculator and kind of go from there. Okay, so what you get here is that x is equal to 12. This would be kilometers per hour. And y is equal to 3 kilometers per hour. Okay, and that's just telling you the speed that the person was rowing at and the other person, like the water, the current was working against it. Okay, so those are those type of problems. Now let's see how this changes up with the next type. Okay, so number 22 is a little bit of a different type of problem. It says a printing company sells small packages of personalized stationery for $7, medium for $12, and large for $15. Yesterday, the company sold 9 packages of stationery, collecting a total of $86, 3 times the median. Okay, so this is a different type of money problem, I guess you could say. Here, this is one of those, like when you see something said, company sold 9 packages of stationery. Okay, so we're selling a bunch of stuff. We sold 9 of them. Okay, we don't know which ones we sold, but we know we sold some of the small, some of the, well, small was S, I guess. S, some of the medium, and some of the large. Add those all together, and there was 9 packages. And that's it. There are no numbers that should go in front of that. So usually when they say there's like a total of something, that's that. Now, dollar amounts like to go together. So let's say $7 for the small amount, $12 for the medium, and $15 for the large. And that's how much money they made with $86. So you take the number of small packages, medium packages. S is the number of small packages. M is the number of medium, and so on and so forth. The last one is the hardest one. I usually like to make sure I word this nicely. Okay, 3 times the medium packages are sold as large packages. So I would usually reword that and say the medium packages there was 3 times, no. I would have said something like, there were 3 times as many medium, no. There was, the medium packages was equal to 3 times the number of large packages. Because this is worded in a weird way that's trying to say, however many medium packages there were, you had to multiply the large number of packages by 3 to get the number of medium packages sold. Okay, and then again, this would move over here. So you're looking for M minus 3L equals 0, and you have a 0S. So keep that in mind. And there you could put all 3 of those in there. This is also, say, one where this one's just asking for you to, say, write a system. So keep in mind, you would have to choose the system that best matches what you're looking for. So system-wise, you're looking for something like this, like something that you would choose for multiple choice. But if you were asked to solve it, you would have to do that. Instead of that third equation, that's the one you would have to use. So 1, 1, 1, 9, 7, 12, 15, 86, 0, 1, negative 3, 0. And then press enter and see what you get. Oh, wait, that's number 23. So let's find out. So when I press enter, I end up with getting 5, 3, and 1 as answers. That means there was 5 small packages sold, 3 mediums, and 1 large. Okay, and that's that for that. So that covers all of those. We're ready to move on. Hey, we're making some decent time. Okay, 24 and 25 are kind of similar problems, but have a slightly different format. And then also keep in mind there's some ways I can show you that the calculator could help you a lot with those. All right, so on 24, you have what is known as vertex form. When you see it in the form of parentheses x plus or minus number squared plus 2, that is vertex form. And keep in mind, just like we said before, the negative tells us about a reflection. Inside the parentheses, a plus tells us to go to the left, a minus tells us to go to the right. A plus outside the parentheses will tell us to go up, and a minus will tell us to go down. So in this one, this plus 3 tells me to go to the left instead of the right, actually to the left 3, but then go up 2. So if I go to the left 3 and up 2, I'm over at this point right here. So that would be your vertex, and you can see that vertex is negative 3, comma 2. Your axis of symmetry will be the x value of that vertex. Your max or min value, it's a min because if you go back, you can say that a positive is a min and a negative is a max, like that, at the very beginning. Okay, and technically this is actually true in any form. The min value here would be 2. All right, so I was going to stick to yellow. Now, if you see the graph of this, and you could actually graph this on the calculator, but by hand we would use the quadratic slope of 135, which would tell me to go up 1 over 1, up 3 over 1, and I don't have room for the 5. You can see here this does not cross the x-axis, so that would be 2 imaginary roots, which means there are no real values to find or anything like that. So NA. Now, If this had crossed, then I would have like said two real roots, and then I would have also have said that there's a, like I would have gone through the calculator, typed this into the calculator, and then did like a menu trace, graph trace type thing to say find out those things. Now again, if you want me to show you a different problem and to show you on with the calculator, I can do that anytime. Just got to ask. Okay, number 25 takes a little bit more work. On this one, okay, there is a little bit of a shortcut, but I'm going to show you how it technically is supposed to be done. So I'm supposed to move this 11, because this actually should be saying x squared plus 6x plus 11. I need to move that over here to the other side. So I've got f of x minus 11 equals x squared plus 6x. Now, here we would say complete the square and say x plus 3 squared, because I divided the 6 by 2. 6 divided by 2 is 3. 3 squared is 9. And then I would say plus 9 over here. That would give me a negative 2. That negative 2 would need to move to the other side. So my vertex form would be x plus 3 squared plus 2, which ends up being exactly 24, but I'm not going to even discuss how that happened. So this would be, again, negative, again, goes to the left and up. So it's exactly, everything else is exactly like number 24. So you can kind of go with that and kind of go, but I can give you all extra problems on that if need be. So this is negative 3, this is a min at 2, this is 2 imaginary, and we know nada. Okay, and there you go. That would be that. Okay, so now we're at a point where we can talk about some square roots. Okay, and that'll probably be it for this section, and then we'll hopefully be done. Okay, so let's look at some of these square roots. So number 25 starts off square root of 18. Now again, folks, I personally like the factor tree method, so I'm going to show you the factor tree method. 18, let's say, is 2 and 9. Okay, 9 is 3 and 3. You got to keep dividing until you have nothing but prime numbers. Your prime numbers are like 2, 3, 5, 7, 11, like 13, and most of the time that's where you end up at. Maybe you get a 23 here and there, or 20, 29, but that's it. Look at your thing like this. Pairs go on the outside, leftovers stay inside. And so your answer for number 25 is 3 square root of 2. Number 26, square root of negative 54. Ignore the negative, because that means we're just going to put an I. Okay? 54 is 2 and 27. Some of y'all stopped at 27. No! 27 is 3 and 9. 9 is 3 and 3. Okay, I have a pair of 3s. That goes on the outside. I have still another 3 and a 2 left over, because I'm looking again at the ends. 3 times 2 gives me 6, and that would stay inside. And there's that one. Okay, notice that one had an I inside the square root. But on number 27, the I is out, or I'm sorry, the negative is outside the square root. So I'm going to keep that negative like that. This would be 2, and that goes into it 96 times. This is 2 and 48. I'm probably going to need to make more space. Let's try this. 2. Okay, so this is 2 and 24, 2 and 12, 2 and 6, 2 and 3. Now keep in mind, you could have actually gone like different numbers and maybe shortened this up a bit. But again, you're only looking at n numbers. So I got a pair of 2s, another pair of 2s, another pair of 2s. So outside I have a 2 times a 2 times a 2, and I have a 3 left over. 2 times 2 times 2 is 8. Don't forget the negative. Square root of 3. Okay, number 28, a little bit easier. 6 square root of 8. Basically, this means you're going to multiply 6 times whatever you get for the outside. Okay, this is 2 and 4, 2 and 2. You got a pair of 2s. Go outside. You have another 2 left over, stays inside. 6 times 2 is 12. Square root of 2, and you are done. Boom! Boom! There we go. All right, so I'm going to go ahead and stop there for this one. That's part 3. Again, I should have part 4. Hopefully that will finish it all up before the weekend's over and well before you have to take your tests. Anyways, that's it for today. Y'all been a great audience. Thank you so much for your time. Y'all take care.